Section 10, question 4. A function f is defined on the set of real numbers by f of x equals x cubed minus 3x plus 2. Part A, find the coordinates of the stationary points on the curve and determine their nature. So the function f of x equals x cubed minus 3x plus 2, to get the stationary points I'm going to differentiate and make equal to 0. So the first thing that I'm going to say there is stationary points exist when f dash x equals 0. So I'm now going to differentiate. So x cubed becomes 3x squared, minus 3x becomes minus 3, and remember to make the thing equal to 0. I'm then going to factorise, so 3 bracket x squared minus 1 is equal to 0. I can divide both sides by 3 and then difference 2 squares. X plus 1 bracket x minus 1 is equal to 0. So the x coordinates of my stationary points are x equals minus 1 and x equals 1. I can now get the y coordinates by subbing back into the original function. So f of minus 1, so that's minus 1 cubed minus 3 lots of minus 1 plus 2. Minus 1 cubed is minus 1. Minus 3 times minus 1 is plus 3 plus 2. And that gives me a y coordinate of 4. So stationary point 1 then is minus 1, 4. I'm now going to find the y coordinate for the point at x equals 1. So f of 1 is 1 cubed minus 3 lots of 1 plus 2. So that's 1 minus 3 plus 2, and that's 0. So stationary point 2 then is 1, 0. Now, depending on what method you've been taught to find the nature, is going to inform what you're going to do next. So either you've been taught nature table or double derivative. So I'm going to first of all focus on the double derivative method and then look at the nature table method. Whichever method you've been taught and you're happy with, just stick to one method and go with it. So as I say, I'm going to start with double derivative. So the stationary points occur at minus 1, 0 and 1, 4. So we've got f dashed x equals 3x squared minus 3. So the double derivative method, what you do is you differentiate the function again. So it's been differentiated to get 3x squared minus 3. You differentiate that again, so 2 comes down and multiplies the 3, gives you 6x. The minus 3 constant disappears. What you then do is you sub in the x coordinate of the stationary point. So the first stationary point occurs at minus 1. Sub in minus 1 and you get minus 6. Now for double derivative method, if the double derivative is negative, what that implies is that you've got a maximum turn point. So what we would say there is f double dash minus 1 is negative, therefore maximum turn point at minus 1, 0. We're then going to look at the point 1, 4. So look at the double derivative at 1. So again, the double derivative was 6x, sub in 1 and get 6. So this time, if you get a positive result, that implies that it's a minimum turn point. So f double dash 1 is equal to 6. So f double dash 1 is positive, therefore minimum turn point at 1, 4. So that's the double derivative method. Double derivative method is, if the double derivative is positive, you've got a minimum turn point. If double derivative is negative, you've got a maximum turn point. Now the case for the double derivative being equal to 0 is something separate that we'll look at either later on in this video or in a separate video focusing on double derivative and nature table. I'm now going to look at the nature table method. So nature table method is that I set up the neighbouring values. So just before minus 1, I could take a neighbouring value being minus 2, between minus 1 and 1, 0, and after 1, that's 2. I then look at the gradient at these points. So the gradient given by the differentiated function at minus 2, 0 and 2. already know that the gradient at -1 and 1, those are stationary points, therefore those are points of 0 gradient. So I'm going to first of all investigate the gradient at -2. So sub -2 into a differentiated function. That's 3 lots of -2 squared minus 3. -2 squared is 4 times 3 is 12. 12 take away 3 is 9. That's a positive result. So I've got a positive here. Then look at my next neighbouring value, which I'm taking as 0. Sub it into a differentiated function. 3 lots of 0 squared minus 3 is -3, and therefore that is a negative result. Finally, look at my neighbouring value of 2. Sub it into a differentiated function. 3 lots of 2 squared minus 3, so that's 12 take away 3, and that's 9, and that is positive again. So what I can see then is that the gradient goes from positive to 0 to negative to 0 to positive, meaning that I've got a maximum turning point at -1, 0 and a minimum turning point at 1, 4, which agreed with the double derivative method. Part B, show that x minus 1 is a factor of x cubed minus 3x plus 2. This is just a bit of polynomials in synthetic division. So remember my 0 coefficient for x squared. So 1, 0 minus 3, 2. Drop the 1 down, multiply by 1. 1 plus 0 is 1. Times that by 1 is 1. Then get -2 times by 1 is -2. 2 minus 2 is equal to 0. So r equals 0, therefore x minus 1 is a factor. Question then says factorise fully. So I'm going to drop this down to get x squared plus x minus 2. Two numbers that multiply give -2, add together to give 1. And that will be x minus 1 bracket x plus 2. And I could write that as x minus 1 all squared bracket x plus 2. Part C, state the coordinates of the point at which the equation meets both axes and hence sketch the curve. So first of all, I'm going to check the x-axis, make y equal to 0. So I'll just make the function equal to 0. I've already factorised the function with the polynomials, but that gives me x equals 1 and x equals -2. The y coordinate as I know is 0, so that's 1, 0 and -2, 0. Now I'm checking the y-axis. I make x equal to 0, sub in 0. F of 0 equals 0 cubed minus 3 lots of 0 plus 2, which is 2, and the point is 0, 2. I could also have made that substitution into the factorised function. That would have been fine as well. I'd get the same result of 2. The question is now looking for me to sketch the curve. So I just need to get all my information, where I cut both axes, the stationary points and their nature, and put them all together in a curve. So I've summarised all the information. I cut the axis at 0, 2, 1, 0 and -2, 0. There's a max at -1, 4. I think halfway through the question I misread that, or miswrote it down as -1, 0 and 1, 4, but it's actually -1, 4 and 1, 0. So a max at -1, 4. I'm in at 1, 0, go through here, here and here, and the curve would look something like this. And that's the final answer to the question.